SPSS.
Oh, I did them in both just to try.
Are you supposed to do them in both?
No, well, the chapter didn't say so, but
because it says to open the class survey, and the class survey is in SPSS.
Right. I copied and pasted into Excel so I could figure out how to use both.
Good. You can show me that later.
Okay. Okay, so what was your questions?
Okay, I'm having a hard time understanding. Hold on, let me find the right question. Okay, so on number 9, where it says 7% is the true unknown percent of population that do not have traditional phones and instead rely on cell phones. Suppose a random sample of 750 telephone users obtained. What is the probability that more than 60 phone users, 8%, in the survey use only cell phones? So it says, what is the mean and standard deviation of the sampling distribution based on 750 telephone users? So I got that, because P equals 0.07,
Yeah.
which is the population.
It's always equal to the mu.
Right. And the standard deviation of P hat is 0.009. 3, but they always have you rounded to 3 numbers, so whatever. Anyway, so, and I got that because you have to do the little square root of and do your whole formula for the P hat, standard deviation for the P hat. So then it says, what is the Z-score you would use? And I know, I mean, I get the
formula.
Yeah, my problem is what the heck is, oh, hold on, let me get there so that I can know what I'm talking about. Okay, what's the P hat in this? I know the standard deviation of the P hat. What's the P hat?
The P hat is the 0.08 because the 60 users is 8%, but the mu users is 7%. So
okay,
it would be 0.08 minus 0.07.
This is in this. That is one of the things I'm struggling with, is figuring out what number is the P hat. Okay.
The P hat, think of it as X and X bar.
It's just that this didn't make sense to me. What is the probability that more than 60 phone users in the survey use only cell phones? I'm like, but wait a minute. They already said 7% is the true unknown percent of, but it's saying true unknown percent. That makes no sense to me.
They word everything here. I really got a kick out of this one. What is the standard deviation of the sampling distribution of the samples proportion of P hat? I'm like, really? Could you have said that any more confusing? So
I think that's what is throwing me off, is when I see 7% is the true unknown percent of the population that do not have traditional cell phones, but then I'm reading, what is the probability that more than 60 phone users, 8% in the survey, use only cell phones? But I'm like, what does it mean is the true unknown percent?
In my opinion, what they're saying here is that in their sampling, where they've sampled the 750 people, the true mean of their sample was 7%.
Do you think they're saying unknown because it's just a sample?
Probably.
Okay. Okay, so then what I would do with the Z-score is it would be the 0.08 minus the 0.07 divided by the square root of the standard deviation.
However, do not use the rounded square root. You will get the wrong answer. You have to use the total square root number, which is 0.0093166515.
Okay.
In the tutorial, he used the 0.0093, but that gives you the wrong Z-score and the wrong probability.
Oh, nice to know. Okay. Okay, so hold on a second. I want to see if this will take it. Did you do it in the square root calculator?
Yeah, but I don't really know how to use that very well.
Well, I'm just wondering if it'll take the whole thing, because it did take the whole, I think it took the whole thing when I did it. Well, it took the whole thing when I was doing the standard deviation of P. So let me see if it'll do it in this population, on the Z-score. So if we do 0.08 minus 0.07, no, I said 0.707. There we go.
I probably,
Divided by, oh yeah, I think it'll do it. The square root of.
okay, wait, so teach me how to do I'm not good with computers and calculators. I'm way better at math in my head. So, so how do you set this up then? Do you use the
Are you
square?
in the square root calculator that we use on Google?
Yeah,
Okay, so do it just the way it shows. Put in 0.08
okay,
minus 0.07
okay,
divided by,
okay,
now hit the square root sign,
okay,
and then we're going to put that in 0.07, and it's times, right?
yes,
Times, and then you're going to put a parenthesis after times. Put times and then put the parenthesis.
okay,
1 minus 0.07 parenthesis divided by the sample, which is 750.
okay.
750, let's see what we get. Equals. Oh, I don't know if that's right.
It's not what I got.
Negative 7.43342883797.
It's not. It's 101.073.
Okay, hold on. So there. All right. Minus 0.07.
You might have to do the 0.08 minus the 0.07, but do the bottom one separately.
I think maybe just like we had to do before.
Yeah.
Square root. Okay. 0.00931665175.
That didn't work either.
Okay, so we have p hat, which is 0.08, right?
Yes.
Minus 0.07 equals
0.01.
divided by 0.0093166.
It's the same answer as your one up top, the standard deviation number.
Okay, so I got 1.07334. Is that
Yes.
not right?
Yeah, and then put it in the probability applet.
Okay, so that's at least right. Let me write down my z-score. 1.0733. Okay, and then my probability applet. There it is. Okay, so if our z-score is, and they're asking what's probably more than 60. Okay, so then we're just shading the right tail, right? 7, 3, right?
Yeah, more than, yes, just the right tail.
So I got 0.1416.
Yes,
Is that right?
that's what I got.
What did they say?
Oh, I forgot to look. Isn't that terrible? Yes, that's right.
Oh, yep, we got it. Okay. Okay, so the area probability is 0.1416. Okay. Yeah, so I think we just have to do it in two separate steps like we had to before. But that's the one thing, that's one of the only things I was getting really confused on was figuring out the p-hat. Because I thought, okay, I know the formula for p-hat, but what would x be?
Where?
Well, the formula for p-hat is x divided by n to find out the p-hat.
X is the number of the individuals which have your specific characteristics that you're looking for. or X is whatever you're looking for. So if in this case, you wanted to know how many people, the 60 phone users would be the X.
But that's why it's the p hat is 0.8, because if you do 60 divided by 750, it's 0.08.
Right.
So really, they've already given it to us. I just was having a hard time figuring out what that number should be. Okay.
Yeah, you have to find the percentage. You cannot use, and then you have to use, from the percentage, you have to use the decimal numbers. You can't use just 60% or 30%. You have to use the 0.03 or whatever.
Right. Okay. Okay, so now here's my other question I have. So is there not a way in SPSS to find out what the exact, for it to tell us what the exact numbers are for each class in the class survey? How do you do that? I got my pie chart, I got my bar graph, but I want it to where it's going to give me my actual numbers.
That's where you go to Excel. Do you want to walk through that?
Well, let's do that after we get our stuff done,
Okay.
so that no one has to watch us do that live.
Okay.
All right. So
Well,
should we go ahead and go to our
that was
quiz?
the last question, unless you had.
Yeah, that was it.
Yeah, that's the last question for
Yeah,
that.
the last thing I just asked you didn't have to do with our preparation. I just wanted to be able to, because I know there's got to be a way to give me my exact numbers.
There is actually.
So.
Let me go to. I don't think I have anything open.
There's got to be some way to analyze something to give us what the exact numbers are for freshman, sophomore, junior, senior, and other.
There is actually in the homework. We were just doing it. So go. Let me find the one that we're working on in the. Go to there's too many pages. I thought there was, but no, it's a whole different summary. If you go, like we were using the no-click in the reading,
Okay.
but then they have a no-click summary where they've already done that for you. So I don't know how to.
Okay.
I haven't tried to learn. I just went to Excel.
Okay. All right. So let's go ahead and do our quiz.
Okay.
And then we can figure that out.
Okay. All right. Let me get scrap paper because I know I'm going to need it. Make you small and move you over. I love having a big screen. I wish my little laptop had a big screen.
I wish I could make myself small.
Oh, you don't. I have gained weight since being home. I thought I would lose, but I'm not.
I'm still in that same situation as well. Okay, I have my normal probability applet open. I also have my square root calculator open. Oops.
Yeah, I need to close SPSS because I'm assuming
Oh, yeah,
that we're going.
good idea. All right, here we go.
Okay. I love 1 and 2.
I know. It's always a gimme. Ones are always a gimme. All right, so in a pie chart, why are the slices, sectors, different sizes? Sizes. I think it's the third one. The fourth one's funny.
Are visually appealing when the slices are different sizes. Yes, I want that one.
Or maybe they should have been there and different colors.
So each slice represents a category, and the area under each slice represents the proportion.
Of the total
Wait,
occupied by the category.
I have a hard time with this computer. Okay. I just went like way down to the bottom and I didn't touch anything. So let me, to occupied by the category. Okay, so how are bar charts and Pareto charts related? Pareto charts are constructed from trossies. They are identical. The only difference between the bi and the pars, the Pareto chart is ordered largest to smallest. Yes.
Correct. Oops, I hit save, but I didn't even hit an answer. Okay. Use the following information for the next 3 questions. We conclude that p hat is normally distributed if sample of p is greater than 10, and the sample times 1 minus p is greater than 10.
Those are just the equations for figuring out if it's normal.
Right. Okay, so is p the true proportion of the sample proportion? It's the sample proportion.
Is p the true proportion or the sample? P is the true proportion.
I thought it was the sample proportion.
I thought p hat was the sample proportion.
Oh, all these letters. You're right. It is the population proportion. This is why you're here.
Well, let's
now we're going into new stuff and new symbols.
hang on because
It says parameter of interest for the population is P. Population proportion.
okay.
It's right here in front of me. P hat is where X is the number of individuals with a certain characteristic. P hat has a sampling distribution. It's the sample. Okay, so you are correct.
N is the sample size.
Yep. Oh, I like that question.
Yeah, me too.
If P equals 1/4, what is the smallest N that satisfies the requirement? What?
If p equals 1/4, what is the smallest n that satisfies the requirement?
Well, we taught that?
Well, just a minute. If p equals 1/4 or 0.25, right? What is the smallest n that satisfies the requirement?
Would this have to do with the equation we used when we were trying to find sample size?
N times p. So if we have, let me do some figuring here. So we have to make, so NP, am I right in saying 1/4 would be 0.25?
I think so. Yeah.
So then we have to figure out what P equals to have it be greater than or equal to 10. So it's algebra.
That's why I'm
No,
saying.
we were not given a question like this. We might have in the reading, but I still have 2 pages left to read, and I haven't found.
So I'm wondering if we go back to formulas for the sample size, which is N equals, and in parentheses, this is all squared, Z star times the standard deviation divided by the margin of error.
But we don't know Z star.
Squared. That's what I'm saying. Do we need to, oh, we can't figure out Z star with what they've given us.
We don't know Z star. So let me try some math. So it would have to be at least would have to be at least 40. Because it has to equal 10.
What is the smallest sample that satisfies the requirement?
So 0.25 divided by 40 equals, oh no, that's not right. Wait, let me see my. Oh. So NP. I need more room. So 0.25.
Okay, so N, our sample size is what?
We don't have a sample size. That's what we're trying to figure out. So our equation is NP equals 0.25 over X is greater than or equal to 10. So just put equal to, because it just, the smallest number has to be equal to. So we're going to divide both sides by 10.
Are you talking, okay, what formula are you doing right now? Like, what are you doing?
I'm doing, so we're doing number 7, right?
Yeah.
If P equals 1/4, what is the smallest N that satisfies the requirement? So the equation, which should be NP equals 0.25 over X equals 10. And we have to solve for X.
So you have NP equals 2.25 divided by X equals 10.
Yes. So we have to solve for X. I think that's what we're trying to do. The other equation might be easier. 1 minus 0.25 equals 10. N.
Well, what divided by, there is nothing divided by 0.25 that would equal 10.
Well, it has to be greater than or equal to, so we just have to have the smallest number.
Okay, so I see why you said 40.
Yeah, but it was wrong.
I'm gonna take the 11:30 bus to get to the airport early. I'm gonna try to catch that 1:30.
Can B take you then?
That, and I was gonna check and see, because
Okay.
he has to work at 12.
Okay, yeah, if you could check that.
Sorry.
I'm having an issue here.
That's why I'm saying I don't think it's,
If P equals 0.25, what is the smallest N that satisfies the requirement?
okay, I think it might be 40 because when I look at my, from the,
I'm
When I-
dividing, not timesing.
I think you're supposed to times it.
Yes, you are, and I, for some reason, am dividing, so it would be 40.
I think it's 40 because when I look at this paper from the PowerPoint, do you see
Okay.
what when I'm looking at that and it says NP
Right.
there, and I put in the bottom because he had said, so you would take 1,041, which is the sample, times it by 0.48, which is the P, and make sure that that is greater than 10.
See, this is where I have a hard time. I looked at it and I said, well, 40 makes sense to me in my head. But when I was doing it in the calculator, for some reason, I divided instead of multiplied. So yes, I believe 40 is the right number. Because if you do 0.25 times 40, it equals 10.
Okay, and if you do n, which we would say it's 40,
Right.
what is that? Times, when you have in parentheses 1 minus p
Right.
is still greater than 10?
Yeah, so 40 times, it'd be 0.75, right?
1 minus point, is p 0.75? No, isn't p 0.25?
5. So it would be n times 0.75.
Huh?
1 minus 0.25 equals 0.75. Right?
Okay, so I don't know, I'm just going to put this in the calculator like it says, because you always do this math in your head, and it confuses me, and I cannot think that way. I do not have a math brain like you.
Yes,
Equals
but this,
30.
right. So that's more than 10.
It is.
But it has to, the first one, 0.25 times 40 equals 10. So that's the smallest number we can have.
Actually, it's supposed to be greater than 10, not equal to 10.
Equal to, greater than, or equal to, look up there above 0.5, above question 5. Greater than or equal to 10.
If p equals 1/4, what is the smallest n that satisfies the requirement? We conclude that p hat is normally distributed and p is greater, that's greater than 10.
The
And
top
n-
one is greater than, the bottom one is equal to.
No, what do you mean the bottom one?
Are you looking at the equation up there above number 5?
Yeah, they're both greater than. There's
We
no equal
conclude
to.
that p hat is normally distributed if np is greater than or equal to 10.
There's no where's the equal to?
It's the line under the greater than.
That's what that is?
Mm-hmm.
I'm not ever meant to do math, ever. Okay. Right. Well, when I've seen a line, it's been below the plus sign, which means plus or minus.
Right. But in this instance, it's greater than or equal to.
Okay, so 40. I agree.
Use the following information to answer the next two questions. Suppose n equals 24 and p equals 0.04
All right, so what is
or
the
0.4.
mean? What is the mean of p hat?
0.4.
Because it's always equal to p, right?
Always equal.
All right,
And this
so
is when we get to calculate. How fun!
what is the standard deviation of p hat? Got it.
So
Right.
the standard deviation
Isn't
from
it the square root of p times 1 minus p over the sample? Right?
yes.
Which means we're going to have 0.04 times 1 minus 0.04 divided by 24, square rooted.
Not 0.04, but 0.4.
Oh, yes, sorry. Ooh, that would have been bad. There's another reason why I'm not good at doing math. Oops, I got to square root that. You could do this whole thing in the square root calculator as one.
Oh, that's nice. Okay, I'll try it.
So you hit the square root square root symbol first,
Okay.
and then put 0.4, and then put a parenthesis, and then put 1 minus 0.4, put another parenthesis, and then divided by 24 equals 0.1.
1, 2, 6, 4, 9, 1, 1, 0, 6, 4. Did you just get 0.1?
I did.
I got 0.1264911.064.
What did you put in? You did the square root.
I did the square root, parenthesis, 0.4 times 1 minus point. Oh, I did point.
You gotta put the parenthesis.
I did, but I put 0.04 instead of 0.4.
Oh. See, you pulled what I pulled writing it down.
Yep, probably just because you said it.
Is be able to take it?
Yeah.
Okay. Hi, Peanut.
Okay, that did not help. I have to do this differently because I'm not getting it.
Let's get in the shower.
Do you want me to tell you what I put in?
Yeah, walk me through it again.
Okay, square, we do the square root symbol.
Okay,
And then put 0.4, and then put a parenthesis,
another parenthesis.
because that's going to times it. 1 minus 0.4,
Okay,
parenthesis,
okay.
divided by 24, parenthesis.
Okay, 0.1.
We'll see if I'm right.
How do you know?
I don't know when we submit it and if it tells us we're right or not.
I'm going to do this one more way. Just a second.
Okay. More questions.
Yeah, because it ends up being 0.24 divided by 24, which is 0.1.
Okay.
Ooh, wait, 0.01.
So are we wrong at 0.1?
I get 0.01 on my calculator.
When you did it on the,
So do the, I'm going to double check on this calculator. So we have 0.4 times, or parenthesis, 1 minus 0.4, parenthesis, equals 0.24, and then divided by 24 equals 0.01.
but you didn't square root it.
Oh, damn. Okay. 0.1. You're right.
I'm just glad the calculator did it right. Because I count on that calculator.
Brittany's batting average is 0.3. We want to determine if the probability she will get more than 35 hits in her next 100 at-bats. What is p hat? Round to the nearest decimal places. P hat,
Is a p hat 0.3?
I think so.
I thought p was always equal to p hat.
It does.
Okay.
What is the standard deviation of p hat?
Oh, we love it. We do the same thing, don't we?
Yes.
0.3. Except for this one, we're going to have to figure out the probability.
We have to go to the app.
So it's going to be a square root of 0.3 times 1 minus 0.3, parenthesis, divided by 100. All right, square root 0.3, parenthesis, 1 minus 0.3, parenthesis, divided by 100 equals, I got
Or
0.4582575,694.
me too. So
Okay,
it would be
0.046.
yes.
What is the z-score?
Z equals P hat minus P over what we just did. P times 1 minus P over N.
Hold on, I gotta write this
So
down.
P hat
Minus p divided by the standard deviation we just did. So what, so p hat minus p, is that
So
gonna
p
be
hat-
the,
046 minus minus
wait,
0.3.
how did you get 046?
We just figured out. Oh, no, we just
No.
figured out the standard deviation.
Yeah, so
No.
doesn't it have to do with she will get more than 35 hits in her next 100? So do we do the 35 divided by 100?
Brittany's batting average is 3.0. We want to determine the probability that she will get 35 hits in her next
Isn't it 0.35 then?
0.35. Yeah, probably.
Because that's what that 0.8 was. 08.
Yeah, so it'd be 0.35 minus 0.30 over 0.04582575694.
Yep. Okay, so if we do 0.35 minus 0.3 divided by
Equals 1.091.
4, 8, 2, 5, 7, 5, 6, 9, 4 equals, I got negative 6.1965367. Let me redo it then.
I'll try this calculator and see what I get.
Okay, so we're doing 0.35
Oh, wait, is it? Yeah, it's minus 0.3.
minus 0.3 divided by 0.04582575694 equals, that's what I get, negative 6.19653670845.
Me too on that calculator. Okay, but on mine, when I do 0.35, because it's p hat first, minus 0.3, so I get 0.05 divided by 0.04582575694. Now I've gotten 3 different things.
Okay, let me do what you just did. You did 0.35 minus 0.3 equals.
Yes.
Okay, and then we're going to divide it.
Divide it by
0.0458 257 5694 equals 1.091.
That's what I got the first time.
1.091. I think we do need to do that because, you know, when you actually, if you were to do the whole z-score, remember we would do the top and get what the top was, then we would do the bottom, and then we would divide them. I think it is this 1.091 08945, whatever, but now we put it in the applet. Excuse me. Okay,
And the question is, what is the probability she will get more than 35? So it's only to the right. 1.091.
091.
So I get the probability of equaling 0.1376.
Yep, that's what I get. So we need to put in the z-score, which is 1.091, hopefully. And Our probability is 0.137138. 38. All right. There we go. All right. If the true proportion of people who supported a political candidate is 0.52, and if N is 2,000 people are surveyed, we want to determine the probability that the results of the survey will suggest the candidate is losing the election, getting less than 50% of the votes. Okay.
Less than 0.5.
Yeah. So
What is the standard deviation?
okay, so this is where we need to do the square root of P times 1 minus P divided by N. Okay, so 0.52 times 1 minus 0.52 divided by N square root.
What is this? Okay.
Square root. Divided by 2,000. Equal, oh, yeah, it's very, okay, equals. I got 0.01117139203.
Equals 0.0001.
You guys.
248. I have to do the, just a second.
Okay. Square root 0.52 1 minus 0.52 divided by 2. Okay.
0.0117139.
Yep. 203.
Yeah.
Okay, so that's our standard deviation of P. So it's going to be 0.011. Now we need to do the z-score, which is P hat minus P. And what's it asking us? We want to determine probably the results of the survey will suggest the candidate is losing the election, getting less than 50%. So is it 0.5 minus 0.52?
I think so.
Minus 0.52 equals I got negative 0.02, and then we divide it by this 0.0117139,203 equals. Okay, I got negative 1.7902871,859.
I got negative 1.790287,191. But it would still be 1.790.
Did you
That's
put
what
the
you
whole
got, right?
thing? Did you put 0.01117139203?
Yes.
Well, that's weird. Okay, but yeah, right. It would still be negative 1.790. So we'll put in the z-score. Negative 1.90. And then we have to do the probability. What is the probability the survey results will show the candidate is losing even though the true P equals 0.52? And now,
What is the probability the survey results will show the candidate is losing even though the true P is 0.52, rounded 3 decimal points? What is the probability the survey results will show the candidate is losing?
are we just doing the left tail then?
Yes.
Okay, well, I got 0.0367, which would be 0.037.
And it's negative 1.790.
Yeah,
Point 0367.
yeah, which means it's gonna be 0.037.
Let me do it first.
No,
Because there's only a couple of us. We
I
need
already
to.
submitted it. So hang tight. We missed one. We missed one.
Which one?
10. What is the P hat? So for some reason, the P hat is not the same as P in that one.
Huh.
Whitney's
That's
batting average is 3.3. We want to determine the probability she will get more than 35 hits in her next 100 at bat. N equals 100 and P 0.3.
we missed this one.
We did.
P equals P hat.
Not in this case, I guess.
Maybe
If we
P
go
hat is
back to the
0.3.
beginning-
Let me try 0.35.
Hold on. Hold on a minute. Okay, P hat equals N divided by, or it equals X divided by N, where X is the number of individuals with a certain characteristic.
Which is 35, I think, in this case.
Then we would divide that by 100.
Right, which is 0.35.
5.
So let me try that one.
Okay.
And that is all correct.
Okay. Let me go back in. Quiz. Start quiz. Okay. Okay, number 7, we figured it was 40, right?
Yes.
Number 8 is 0.4.
Hang on. 2 is each is the third one. Number 4 is the last one. Okay, so 5 is true proportion.
6 is the sample size. 7 is 40.
Yes.
8 is 0.4.
Yes.
9, was that one 0.1?
Yes.
10, we figured that one to be 0.35.
10 is, yes, 0.35.
Okay. 11,
0.046.
12,
1.091.
1.091. 13,
0.138.
14,
0.011.
15,
Negative 1.79.
16.
0.037.
All right,
Feedback?
yep, for 16, I have 0.037.
Yes.
For 15, I have negative 1.79.
Yes.
For 14, I have 0.011.
Yes.
For 13, I have 0.138.
Yes.
For 12, I have 1.091.
Yes.
For 11, I have 0.046.
Yes.
For 10, I have 0.35.
Yes.
For 9, I have 0.1.
Yes.
For 8, I have 0.4.
Yes.
For 7, I have 40.
Yes.
6 is the sample size.
Yes.
5 is true proportion.
Yes.
4 is the last one.
Yes.
3 is the third one.
Yes.
Okay. Save.
0.37, negative 1.79, 0.11, 0.138, 12 is 1.091.
Done. Awesome.
Okay. I'm going to stop the broadcast.
Alrighty.